I'll be discussing the problem coin change. You are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combinations of the coins, return -1. You may assume that you have an infinite number of each kind of coin. So the coin chain says that we cannot be greedy if we want to solve this problem. The brute force that we take out is DFS backtracking. Our decision tree would have the amount of choices. If we chose a coin which comes greater than the amount, then the result should be -1. We found one possible way where I actually drew a decision tree where we found one possible way where we can sum up to the amount. We found an algorithm that tells us the possible solution, and we need to set minimum coin variable to that possible solution. As we traverse through left subarray, we can see the sub problems repeat themselves. Do not compute those sub problems and just borrow from previously calculated possible solution. We need to stop searching whenever we encounter -1. We replace minimum coin if at any stage we find minimum amount of coins needed to total to amount 7. And then we need to store the result of the sub problems in a cache. The summary, so there is, while I was solving this problem, I could not understand from the neat codes video. So I actually referred to some other, YouTube video as well, where the explanation was given as the problem seems same as the knapsack problem, where we need to keep the track of previous calculation and use them for future ones memorization. DP, this solution uses recursion with memorization to compute the minimum number of coins needed for each sub amount from amount down to 0. The coin change method initializes a memo dictionary self.memo where 0 maps to 0 coins and any coin value itself maps to 1 coin. Then it calls the recursive helper function which checks if the answer for the current amount is already stored in the memo, and if yes, then it returns it immediately to avoid recomputation. The summary pattern observed while solving this problem is first climbing stairs, house robber, perfect squares, minimum path problems, unbounded knapsack, rod cutting, edit distance, 1D optimized version, and then decode ways, and then integer break. So I have also taken out the top 10 problems which actually match the same kind of pattern, and I don't know why I'm not understanding this coin change problem, but I need to revisit this problem again and again just in order to understand the dynamic programming intuition.